And good morning, ladies and gentlemen. This is Mr. Kasarian, and welcome to an episode that is not of my Let's Play series, but it is in fact a Minecraft episode. In fact, today we are going to be working with Industrialcraft. I'm actually going to be starting an Industrialcraft tutorial series, and I actually tried to start this a while ago, but didn't get very far in it. So we're here in my nice little flat university world, and well, let's start covering first of all how to generate power. So if I open up my item subsets, I can focus on my IC2 stuff. There we go. Nice. Looks like we got basically everything here. Now the first thing you're going to be working with, actually, is going to be your most basic type of generator, which is the generator. Kind of looks like a furnace, doesn't it? Well, that's because it's very similar to a furnace. Combustibles go in the bottom, they get burned up, and they generate power. Pretty simple, right guys? I think so, at least. Now, you have to constantly provide it consumables, but it does generate a nice amount of power, and it's cheap. In fact, let's take a look at its recipe right here. Furnace, machine block, and an RE battery. The machine block and the RE battery we'll get to later, once we get into more crafting information. But suffice to say, the total cost is about 4 pieces of tin, a little bit of copper, a little bit of rubber, and some other materials. Okay, so now that we have our generator, how exactly do we power it? What do we do? Well, quite simply, we throw a combustible in. I'm going to use some coal. All right, throw the coal in. You can hear the generator running in the background. Now, a lot of Let's Players actually turn their audio files, their sounds off for IC2, but I actually quite like to hear it. So the generator is generating. You can see this red bar is rising. That means its internal buffer of power is increasing. Generators store power internally. Notice it filled up, the generator depleted the coal, and it actually stopped burning. That's because the internal battery is full. Now, just for test purposes, let us get ourselves a mass fabricator. This is an advanced machine that we'll run into later. But for right now, we don't have to worry about it much. Simply by placing the mass fabricator next to the generator, power is being transferred. You can see the mass fabricator is going, the generator is running. However, get our wrench here. Now, some things are very different for me now. Because I am running with GregTech installed on this instance. Don't worry, I'll try and filter out the differences and let you know of them as I run into them. Now, the first thing to notice here is that the generator stopped running, of course. The mass fabricator wasn't using energy. The mass fabricator will use as much energy as possible. Let's get ourselves a bit of a smaller machine. Let's get ourselves a macerator. Okay, so the macerator has its own internal buffer. Now, we'll get to the macerator and what it does later on, but suffice to say, it grinds stuff into other stuff. So let's get some cobble and throw it in. You can see the macerator is now running. However, if we check the Industrialcraft wiki, the generator, our good old-fashioned generator, pull it open here. The generator gives you 10 EU per tick. That's actually pretty decent, at least early on in the game. It's your most basic generator, so don't expect too much from it. However, the macerator only uses about 2 EU per tick. Well, what's happening here? Well, quite simply, the other 6 energy units per tick are being wasted by the generator. They're going nowhere. So, for heaven's sakes. So, let's pull up our macerator. And let's see how we can recoup some of that energy loss. Well, rather than wasting the energy, why don't we try and store it? To do that, we're going to use a bat box. The bat box is pretty simple to make. See that right there. And it gives us a unique advantage. It can store EU. Now, if you look at the bat box, you can see that most of the sides are blank. One of them has this dot on it. That's because the way IC2 power works is that energy flows like water. There's an input and an output. In the case of this block, there's 5 input faces and 1 output face. Now, with our wrench, we can actually turn that. Simply click in the middle of the block, it turns the face. For those of you who have GregTech installed, you can also click on the sides of the block like this. Now, if you notice, I didn't place it directly next to my generator. Why is that? Well, it wouldn't be much use to simply transfer from one generator to one bat box to one machine, now would it? Well, to do that, we're going to need some wire. Excuse me. IC2 calls it cable. And we're going to use the lowest tier, copper cable. Uninsulated copper cable is made like so. And of course, we have to insulate it with rubber. You can insulate it like this, or you can insulate it like this. Ignore the rubber bar that's showing up there. That's actually from another mod that is also offering an alternate crafting recipe. So to connect these, all we do is we connect any side of the generator to one of the 5 input faces of the bat box. You can now hear the generator is running, and the bat box is charging. You can see it can store 40,000 energy units. Now, if you notice, it says its output is 32 EU per tick. That's because IC2 has several different voltages. Okay? Voltages are determined. Let me turn my flight mode on for a minute. Voltages are, in essence, the measure of energy units. Now, to get into a bit of theory here, IC2 isn't a straight flow of energy. Every tick this generator creates a packet of energy, an 8 EU packet to be precise. That packet is then sent into the network, which is very simple, and stored in the bat box. All right. Now, what happened? Now, what does it mean by 32 out? Well, that means that this bat box will output a 32 EU packet every tick. That is what we call low voltage. Let me get a sign here and I'll show you. So low voltage is 32 EU per tick. Okay? And essentially any cable can carry that voltage. The only cable that can't is the ultra-low current cable. The ultra-low current cable, which is made of tin and uninsulated, by the way, in essence, what's the best way to explain it? It's really only used for devices such as the solar panels. It can only handle a 1 EU packet. All right. Now, what happens if you try and use a cable that isn't rated for that voltage? Well, let's put this down here. Nothing's happening. Why is that? Well, the Industrialcraft energy system basically relies on a request basis. There's no machine down the line requesting power, so there's no reason for the bat box to send any. The second I put down my macerator, whoa, what happened to my cable? Well, the cable wasn't rated for that voltage, so it blew up. Ouch. Okay. So the bat box outputs low voltage. Let's pull up the bat box for a second. And let's take a look at the MFE. The MFE is the second tier of energy storage. We can take a look at the recipe. It uses energy crystals and gold cable. Fun. If we put our MFE down, we can see, okay, that's not too bad. MFE, pretty decent. So let's get ourselves some copper cable. Let's hook this stuff up. Oh, what just happened? Well, first of all, you noticed that the cable itself fried. Of course, copper cable is only rated for 32 EU per tick. Items going up here will be in order of their maximum possible voltage. The MFE outputs at 128 EU per tick, which is medium voltage. Okay, so as soon as it hit that wire, it failed to work. Fun, right? Right. Now, why did the machine explode? Well, the machine is also rated for a certain voltage. In fact, most basic IC2 machines are only rated for medium voltage. Oof, so we have a problem now. Well, to deal with that, we're going to get ourselves some gold cable. That'll solve our cabling issues. Gold cable, which actually has to be insulated twice if you take a look. Gold cable, insulated, and twice insulated. That can connect it to the MFE. However, gold cable cannot, in fact, if you notice, they do in fact connect. Gold cable cannot, in fact, carry any higher voltages than medium voltage. So now how do we deal with the fact that our machine can only accept low voltage wire? Well, we need something called a transformer. You can see there are three different types of transformers. Now, they're named by what they transform the energy into. So an LV transformer will take MV current and transform it into LV current. We place it down. We see there these five of the faces have one dot on them. That's the output. One face has three dots. That's the input. So let's spin it around. Get out our copper cable. Get another macerator. And hook it up. This time, if you notice, the macerator isn't exploding. Nice. Now this is a good time to show you something. It's called the EU reader, and it's actually really useful to have as you're working in IC2. If we right-click, you can see it's starting a new measurement. 10 in, 10 out. Not bad. 0 gain. 10 in, 0 out, 10 gain. Now that's a misleading number because it actually is, yes, okay, see now, it is transferring energy. It's just not showing up sometimes, okay? If you notice, the LV transformer doesn't have an interface. That's because there's nothing to interface with. It does one job, and it does it remarkably well. All right, so we have our macerator here. We know it's not drawing a lot of power. That's nice. What about our mass fabricator? Let's drop that down. It's running. How much power is being transferred? 128 here. Whoa, 128 here. How's that happening? Well, that's because... Remember I said this could only handle packets up to size 128 energy units? Well, that doesn't mean there can't be multiple packets traveling through the same wire per tick. So, another example is, let's say you have a bunch of machines on this line. Let's say they're drawing 200 EU per tick. I know that sounds incredible. Believe me, it can happen quite easily. 128 EU per tick is being drawn on this line. Well, that's much more than this MFE can supply. Even if I have plenty of power being generated back here. Okay? How would we deal with that? Well, let me give you a test case. Let us get some solar panels, and we'll get to how these things work later. Each of these panels, suffice to say, will generate 128 EU per tick. So let's go 1, 2, oops. 1, 2, up, cable burned, 3. Okay. And we will want to move them back a couple spaces. So let's put it back here. Right about here. Oh, for heaven's sakes. There we go. Okay. Now, if, for example, we connect all these together, connect them all in, and then we'll take a look at what this line looks like with our EU reader. 189. I guess MV solar arrays generate less than I thought they did. 189 EU per tick. If I detect this one, 63, so about 64. Okay. So this is about 189. Now that's far more than this. That's more than this MFE can actually deploy out in front of it, right? Which means that no matter how much we try, we'll only have 128 available on this line, and we have more production than we can transmit through. Now, if I got another MFE, 2 more in fact, and put them down like this and like that, what do you think is going to happen here? Well, what it's going to do is it's actually going to be outputting multiple 128 EU packets on this line at the same time. So if I took a look at this, where everything's charging up, that's not bad at all. Let's throw it in our mass fabricator and take a quick look at this line. 128, 59. It's actually splitting the power in between these MFEs. So if I take a look at this, 128 in. But there are multiple packets available on this line. So for example, if I ran another cable, and I got another mass fabricator, interesting. Ah, yes, that's right. So in this instance, the transformer is actually creating issues for us. Now, if we got out our EU reader, you can see that we actually have far more power available on this line. The LV transformers can only transform 1 packet at a time, in essence. So they are sending the packets through, but they're creating a bottleneck in the lines. And this sort of circle was bad. Avoided, please. Okay. So in a basic example, we're actually putting much more power available on a line than you would suspect. Now, it just so happens that these mass fabricators can actually be connected to MV power. Now, if we took a look at this, 370. So we have all of the power available from these MFEs because they're all generating they're all generating 1 packet. So we have 3 128 packets available on this line at once. Not too shabby. All right. So now let's take another step up. All right. Let's get ourselves the mother of all energy storage, the MFSU. This device stores a frankly ridiculous amount of power. 10 million EU. And it outputs at 512 EU per tick. High voltage. All right. So let's throw up our little sign here. Let's say high voltage is 512 EU per tick. And what type of cable can carry this much power? We're looking at the glass fiber cable. The glass fiber cable, made like so, yep, that takes a diamond all right, is sort of the cream of the crop of energy. It can store it can transmit incredible amount, 512, and it also has the lowest energy loss over distance. This is something I have not gotten to talk about yet. As your cable networks become longer and longer and longer, they start to lose efficiency. Our good old-fashioned copper cable over here loses 1 EU every 4 blocks. Glass fiber, I believe, is 1 EU every 30 blocks. Not too shabby. Not too shabby at all. Now, IC2 is nice, and it actually rounds the energy loss down. So you won't lose any energy until you hit the 30 block limit. After that, you won't lose any more energy until you hit the 60 block limit. All right. So you have our MFSU and our glass fiber cable. Not bad at all. And again, the same rules as with the MFEs and the bat boxes do apply. Now we have one more type of energy, of voltage, to take a quick look at. That is somewhat scary. It's called extreme voltage. All right. Extreme voltage is only generated by a very, very few machines. Very, very few machines. Pull this open. There we go. So, Extreme voltage is... How to explain this? Extreme voltage is roughly 2048 EU per tick. That's a 4. Now, the reason I say roughly is that very, 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 pretty much no vanilla IC2 machine can output that much power, or in that packet size per tick. It just doesn't happen. The time you usually see it is when you take a, let's get ourselves an HV transformer and a high voltage solar panel. Stick it right on top of the We'll stick it right on top of the MFSU like that. Okay. The only time you see it is when you take an HV transformer like so, and you apply a redstone signal to it. Now, if you apply a redstone signal to any block like this, it will upconvert. So if you applied one to an MV transformer, it would convert up to high voltage. Make sense? I hope so. Now, of course, as soon as we connect something to this line, let's say we put a mass fabricator over here and some glass fiber. Interesting. Ah, right. Ow. Yeah, don't do that. Like, seriously, guys, don't do that. Ouch. What type of cable? If you notice, right before the massive explosion, the cable went out. What type of cable can we use? Well, our only recourse would be the 4x insulated high voltage cable. 2x insulated and refined iron. It is probably some of the, I would say, scariest stuff I've ever seen. It's a full block in size, almost a full block in size. And it's pretty much the only way you're going to be able to transmit this sort of power, at least in vanilla Minecraft, or vanilla IC2 rather. If we took our MFSU, and plopped it down, we threw this back down, and let's say we got ourselves our glass fiber cable, and our HV transformer again. Looks like we did it wrong. Let's get ourselves a lever. Another HV transformer. We brought this one all the way over to here. And then we connect them. This is one heck of a line, isn't it? And let's get ourselves another MFSU just to create the power flow. All right. As you can see here, power is not yet flowing in. Flip the lever. This is one heck of a power line. The reason you'd use this is because your energy loss is cumulative over the number of packets you're transferring. So in an instance like this, you'd want to basically condense the number of packets you're trying to transfer at a time. So you'd upconvert it, send it your wicked long distance all the way over to here, downconvert it into something you can actually use. But this brings me to my next point. What happens if we take cable that's uninsulated? Straight up HV cable. Let me get back a little bit here. Ah, it's not even going to connect. because I wasn't close enough and on the right block. What happens if I get close to this stuff? Ow. Ow, 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 ow. Okay, I'm wearing one of the best armor packs in the game. And it just took me down by a lot of health. Now, if I'm correct, power is no longer transferring. So I can do the cha-cha on top of this thing and I'm okay. Always remember to insulate your cables. If you don't, they will try and kill you. Good? Good. Alright, so if you give me a couple minutes, I'll be right back, and we'll start talking about alternate methods of power generation in detail. Actually, ladies and gentlemen, I think this is a good place to wrap up this part of the tutorial. So we now have the basics of energy storage and energy transfer. In the next episode, we'll actually start with talking about the details of energy generation. So on that note, ladies and gentlemen, I hope you found this information informative. And so yes, if you enjoyed this and you learned something, or you didn't learn something but think others would, please give this video a like, maybe throw me a comment on anything I missed, or a subscription. Alright, thank you very much, ladies and gentlemen, and as always, happy mining.